Hello guys, welcome back and good day. Today this will be our 11th lesson for our ETAP software tutorial. We will be performing cable sizing, okay, and uh, for cable sizing, we have two criteria to be considered. First, to size the cable, we need to apply the rating factor to finalize our cable ampacity or uh, cable current carrying capacity. Next, also we're going to verify the voltage drop. Okay, so right now we don't have a prepared single line diagram, so we're going to provide or to draw a single line diagram from scratch. Okay, so now let's provide here our power grid. Okay, this is our power grid. Next, this will let's provide here a bus. Okay, a bus and a two winding transformer. Then bottom for our two winding transformer is also a bus from here. Okay, and here we're going to propose a lamp load. Lamp load, by the way, is a composed of motors and static loads. Okay, so let's interconnect all these electrical components. Okay, first let's connect this lamp load. Okay, to the bus and also the transformer to bus 2. Okay, the primary side to bus 1 and our power grid to bus 1. Okay, so right now we're going to provide a data on our power grid, on our two winding transformer, on our lamp load. So let's provide first on our power grid. Okay, let's double click on this and let's provide the short circuit, okay, rating, AMBA short circuit rating of our power grid. Okay, let's say around 100. Okay, and the XR ratio is 25. Okay, next let's click OK on this. Next, let's provide information to our transformer. Okay, and the rating of our transformer, let's say, let's make it in kVA to be 1000 kVA. Okay, on our primary side, okay, primary voltage will be, let's say, 13.8 kV. On the secondary side of the transformer is 480 volts or 0.48 kV. Okay, for the impedance, okay, so for impedance and XR ratio, we're going to take it from ETAP library. So we'll just click this here, the typical Z and XR. Okay, and we have this information already for our impedance, XR ratio, and the rest of Rx and the rest of %X and %R from here. Okay, and let's click OK on this. Okay, so since we have provided the voltage on our transformer, ETAP has automatically assigned, okay, the voltage rating for our bus 1 and our bus 2, which is 13.8 kV for bus 1 and 0.48 kV for bus 2. Okay, next we're going to provide our power cables on the primary side of our transformer and the secondary side of our transformer. So let's move this one a little bit down, okay, so that we have enough space for our cable. Okay, so now let's provide in cable on our primary side of our transformer. So this will be our cable 1 and also on our secondary side of our transformer. So this will be our cable 2. Okay, so now cable 1 and cable 2, this will be our subject for discussion, wherein we're going to verify its current carrying capacity or the ampacity of the cable by applying its derating factor. and also we're going to verify its voltage drop. Okay, so first let's provide here the size of our cable. By the way, the size of our cable, we're going to take it also the information. We're going to take it from the ETAP library as well. Okay, let's double click on this, and let's say the length of the cable is around 50 meters. Okay, and let's click on the library. Okay, and let's assign now. Okay, so now we are selecting this cable. Okay, frequency 60 Hz, copper, rated 15 kV because our system voltage is 13.8 kV. It's 3-core cable, XLPE. Okay, the insulation is XLPE. And let's say we're going to select it here, 50 m square cable. Let's click OK on this. Number of conductor per phase, let's select one conductor per phase. Okay, and also from here, the impedance, let's change this one, ohms per 1 meter. Okay, and let's click OK on this. Okay, next, we're going to provide on our secondary side of our transformer for the cable 2. Okay, let's say the length of this cable is 100 meters. Okay, and let's select from our library. Okay, so from here, we're going to select this rated 60 Hz copper. Okay, rated 1 kV since our system voltage for our secondary is 0.48 kV. 3-core also, and the insulation is XLPE. So from here, from these choices, okay, we're going to select 400 mm square. Okay, cable, and let's click OK on this. So for the meantime, let's provide one conductor per phase. Let's evaluate on this. Okay, so let's click OK. Okay, and now we're going to run, okay, a load flow analysis. So by clicking load flow from here, first we're going to update our study case. Okay, so from our study case, ensure that we have at this update from here, the cable load arms has to be checked. Okay, so that it will it will provide information on our screen. Okay, so let's click OK on this. Okay, and let's go first on display options. We required only this voltage drop. Let's click also this one. Okay, and line per cable, and also we require the information for amperes. Okay, let's click only amperes. Okay, and let's click OK on this. And we need to check this unit so that we understand the information once we run the load flow study. Okay, the information given on our screen. So let's click this unit right now. Okay, so but before that, let's go back first on our cable. Okay, let's go to the ampacity of our cable. Okay, so from here, we're going, this is for performing cable sizing in ETAP. These three areas here, the standard, the type, and the grouping, is important to have the information. Okay, so for example, in our study case right now, we're going to select, okay, for the type, let's say, all underground buried. Okay, and okay, so from here, we have here choices IEEE 399, in EC, okay, and IEC 60502. So we're going to adopt the IEEE 399 standard. Okay, this type of, from here we have several choices. We have underground duct, we have underground buried, above ground trace, but in our case we're going to choose underground buried from here. Next, the grouping, let's say 4 rows and let's say 6 columns. Okay? Okay, so here, allowable ampacity capacity, let's check or choose this derated here. Okay? So we have already chosen this derated from here. And let's click OK on this. Okay? Next, on the cable number 2, let's go to the ampacity. From here, the same, we're going to install this cable as underground buried. Okay, and let's choose IEEE standard 399. Okay, so for the grouping, let's say here 6 rows, and this will be installed uh, along the grouping will be 6 rows and let's say 8 columns from here. Okay, so here, let's ensure that this is because we are applying the derating factor in terms of how it is installed and how it is being grouped. Okay, so let's choose here. Let's check this one, this derated, and let's click OK. So right now, this the system right now is ready to run for load flow. Okay, so let's run for load flow. Let's click this one. And output file name, let's say LF. Okay. Okay, so the rated MVKB lamp load must be greater than 0. Okay, so we did not provide the information from our lamp load here. So here, nameplate, okay, let's say our rating here is 700 kV, 700 kVA. Okay. So, click OK in this. And let's run again our load flow. Okay. Okay. So, right now, our bus 1 is 100%. Okay. And our bus 2 is too huge. Is 83.94%. We need to check so what's really the problem from here. Okay, so here, see the cable 2 is right now is red. So it's in critical value. Okay, and we have here on our on our cable 1, we have here in our cable 2, we have here 9.64% voltage drop. Okay, so let's check first the information from our cable 1. Okay, let's go from here from our impedance. Okay, ohms per meter, 1 meter. Okay, just hold on. And let's link this one on the library. Okay. And the cable 2, let's link this one on the library as well. Okay, and our impedance, ohms per 1, see? Ohms per 1 kilometer. That's why we have here a huge voltage deviation rather on our bus too, because it's written here ohms per 1 kilometer. It's supposed to be ohms per 1 meter. Okay, let's click OK on this, and let's again run our load flow. Okay. Okay, so now we have here already 90 on our bus 2. We have already 94.06%. Okay, so let's evaluate now because we have an issue on our bus 2. Okay, but right now for our topic for discussion, we're going to assess only on our cable 1 and cable 2. Later also, we're going to resolve this issue on our bus 2 since it's in critical value, which is 94.06. Okay, let's go first on our cable 1. Okay, so from our cable 1, let's go to our ampacity from here. Okay, here, our cable 1, it is operating 30.42 amperes. Okay, so this one 30, okay, this one 30.4, okay, operating. Our cable is rated 191 amperes, so this is okay. After the derating, after the applying the derating factor, we have now our size, this 50 m square cable, okay, after the applying the derating factor, it's now 80.9 ampere. It's still okay because our system is only operating 30.42 amperes. So we can check from here, our loading from here. Okay. So phase A, let's say this system is balanced. Phase A, B, and C is operating 30.42 ampere. So from here, we don't have an issue on our uh, on our, let's say, on our cable size. But we need to check here our one of the criteria also. Okay, from here, let's check the voltage drop. Okay, so from here, we need to ensure uh, we assign here that the voltage drop is 2%. For example, how about I want to be the voltage drop here to be 1%? Anyway, it's okay because here the voltage drop is written 0.02. Even if you change this one by 1%, okay, the actual voltage drop of this cable 50 mm square is still 0.02%. Meaning, our size right now, okay, our size right now is with 3 core 50 mm square is sufficient enough to carry the actual line current, which is 30.4 ampere. Okay, ETAP has recommended from here 25 mm square, but we don't change this. Let's stick on our size to be 50 m square cable. Okay, so that is for the primary side of the cable. Okay, so let's close on this. Let's click OK from here. Let's go on the secondary side because our secondary side of the cable has having a critical value. So let's double click on this. Let's go to the ampacity. Okay, so from here, it is operating 874.5 ampere. Okay, let's check again. Let's run this load flow. Just hold on. Let's click on this. So we can see the actual, see, 874.5 ampere. Now the cable is in red right now. So why? Because from the ampacity, the actual current here flowing in this line, it is 874.5 ampere. And our cable, our proposed one, we propose here 3 core into 400 m square, right? The base is only 635 ampere. After applying the derating factor, now the cable is rated 232.3 ampere. Meaning, okay, just let's close this one. Meaning, you check from here, this cable, so the rating is 232.318 ampere and it is operating around 376.4 percent. Okay, so almost times 4. Okay, so let's open this. From here, we can check also the loading. Okay, so right now, the average, the loading on our on secondary side is 874.5 for all the phases, for phase A, phase B, and phase C. Okay, so right now, we'll go to this sizing, this one, sizing phase. Let's check this. Okay, and okay, so maximum voltage drop. Okay, it's let's select this one as 1%. Okay, and here ETAP has recommended the first option from ETAP. Okay, the first option is to provide four phase per conduct, four number per phase, 400 mm square size, which is the rated is 929 ampere. Second option provided by ETAP is to change our cable by 4 number per phase, 300 mm square. Okay, so why ETA providing this two option? First, the optimal size. The second one, the one size is smaller, because sometimes, for example, in our lamp load, we have some motors. Some motors are running intermittently. Okay? So it's not continuous. Okay? So we need to evaluate that one, whether that intermittent function of some motors, for example, motor will run only for 5 minutes or for 10 minutes. So it's not necessary to choose the optimal size. We can choose the smaller size. But for conservative approach, it's better to have use the optimal size of our cable, which is 4 sets of 3 core into 400 mm square. So right now we're going to select right now what is being recommended by ETAP, and let's run again our load flow. Okay, so let's select on this the optimal size. Okay, and let's click OK on this. Then, since we have an issue on the bus critical value, okay, so let's change the top setting from our bus into -5 on the primary side. Okay, and now let's run again our load flow analysis to check, okay, to further check the recommendation from ETAP. Okay. So right now, our bus for bus 2 is 101.8% against the nominal voltage. So right now, let's check on our the critical alert view from here, the alert view from here. So we don't have here is empty already, because we have an issue on our cable 2, right? Okay. So here, we have changed it already. This before it was one conductor per phase. ETAP has recommended to make it 4 conductor per phase. Okay, so that's why we have resolved the issue on our secondary side of the transformer cable. Okay, so let's click OK on this. Okay, so I think this is we are ending our discussion, as we have already tackled all the necessary steps on how to size power cable, okay, by applying derating factor on the cable, and also establishing the voltage drop of the cable. Okay, thanks for watching.